where are the trade-offs, where are entry points in the nexus that might only have opened up because of climate change impact. So I think those are some of the issues we want to discuss today. And we will start this session not by having everyone sitting up at the beginning, because the presentation screen is right behind those white chairs. So instead we'll directly start with the two keynote presentations, and then we have the panelists coming up to the podium and give their remarks. So with no further ado, I'd like to introduce our first keynote speaker, Dr. Stefan Ullenbrook. He's the Strategic Program Director at the International Water Management Institute, and he's also the Director of the CGIAR Research Program on Water, Land and Ecosystems. And he will give, I think, an overall overview on the water, energy, food environment nexus and how this is linked to resilience and to building resilience. So can we get Dr. Ullenbrook on the screen? And also so that he can share his presentation. Let's see. Okay, the magic is working hopefully behind our great logistic support. We know he's online, which they just have to switch it the screen. Okay, it's a first time. Will he be able to share his screen for his presentation? Also, can we hear him? Yeah. Stefan, can you share your screen? Can you say something so that we know that we can hear you? Okay, does not yet work. If not, we'll start with the second presentation if we can't get Stefan in at this point. Okay, so then let's first start with our second speaker, Dr. Kahraman Jumoboev. Please pronounce your name yourself after. So he's a senior researcher at the IWMI office in Tashkent, Uzbekistan, and he will give a similar opening talk on the water, energy, food, environment nexus. So what are some of the issues and challenges, focusing on a more transboundary context in Central Asia, the I think very famous Aral Sea Basin, where environmental and ecosystem health has been dramatically altered by irrigation for cotton production, but also for some food security crops. So over to you, Dr. Kahraman, and if you could please also tell us your name again, because I surely didn't pronounce it very well.
My name is Kahraman. My last name is Jumoboev. I work for International Water Management Institute, Central Asia office. Our Central Asia office is located in Tashkent, Uzbekistan. And today I am going to present, water energy use efficiency and application of WEF nexus approach in transboundary context. And I will bring some case studies from Amudarya and Sirdarya River Basin from Central Asia. So, could you please share my presentation? Before, I think until they fix, I can give some information about Central Asia. Central Asia, it's in the Aral Sea Basin and covers 5 countries: Uzbekistan, Tajikistan, Kyrgyzstan, Turkmenistan, and Kazakhstan, and also some part of Afghanistan. So we have two transboundary rivers. One of them is Amudarya, which is shared by Afghanistan, Tajikistan, Uzbekistan, and Turkmenistan. And another one is Sirdarya, which forms in the territory of Kyrgyzstan and shared by Uzbekistan and Kazakhstan. Yeah, and next slide, please. Yeah, and this map clearly describes, RLC Basin. RLC Basin is home for more than 80 million people, and we share this Amudarya and Sirdarya, which I showed you. And on the top, there is Sirdarya, which forms in the territory of Kyrgyzstan, and also, it used to feed to RLC before until 1990, but nowadays, due to a lot of developments in upstream and middle stream of the river, diversion of water to different sectors of economy, it's not reaching to the RLC. And in the lower, there is Amudarya River Basin, which forms in the territory of Afghanistan and Tajikistan, and it provides water, in the downstream, Uzbekistan, Turkmenistan, and also Tajikistan uses this water. And in Central Asia, we have about 15 billion cubic meter of water available from these two rivers, and 90% of the water is used for irrigation purposes, for agriculture. And the remaining it's used for hydropower sector, for energy use, for energy generation, and also for other purposes. So Kyrgyzstan and Tajikistan is considered like upstream country, and Uzbekistan and Turkmenistan is considered, Kazakhstan is considered as a downstream country in this river, in transboundary rivers. Next slide, please. Nowadays, due to a lot of developments, population growth and climate change, and also emerging other challenges, demand for water, for energy, and also for food production is increasing. And in Central Asia, we have less rainfall. In plain areas, rainfall varies from 200 mm up to 400 mm. But in mountainous areas, it varies from 400 up to 600 mm. And most of the rivers are glacier filled. And we have high evapotranspiration. For example, in Fergana Valley, ETO, varies from 1,200 up to 1,600 mm. So, which indicates that there is big gap. So, all crops must be irrigated in order to get good crop production. And according to the World Bank report, Central Asian countries are most vulnerable to climate change, and we are facing frequent water shortage, and there is also, drought issues and also flood issues in upstream. And farmers use conventional irrigation practices that leads to excess drainage water runoff from irrigated areas. And also, these inefficient practices leads, to return flow and, causes excessive consumption of water in pump irrigated areas. So another issue is that, for example, upstream countries, they have huge potential for hydropower development, and downstream countries, they have huge potential for irrigation. So there is also, a conflict of interests. For example, upstream countries, they would like to store water during summer period, and they need energy for winter period in order to generate electricity. But downstream countries, they need water for summer period in order to cultivate crops. Also, all Central Asian countries, they share transboundary rivers, but they do not have regional planning. I mean, we do not have water allocation plan for Central Asia, but all plans are developed at national level. And all these national strategies on water use are directed more water abstraction than sustainable use of water resources in different sectors of economy. So, and on the right side, this map describes pump irrigated area. So you can see there is Amudarya, and we are pumping water to this red delineated area, which is irrigated area. And it's about 335,000 hectare, one of the pump irrigation scheme. And during Soviet period, during hydraulic mission, we have developed such kind of irrigation schemes, and the pumping height varies from 150 up to 600 meters in some places. And we are not pumping groundwater, we are pumping water from Amudarya or Sirdarya to higher elevation in order to irrigate crops. And in Uzbekistan, for example, we have 4.3 million hectare area. About 50% of that area under pump operation, under pump irrigation, and it consumes about 20% of total available energy of the country. In Tajikistan, for example, about 750,000 hectare irrigated area, and almost 80% area under pump irrigation, 40%, and it consumes about 16% of total available energy of the country. And this is huge amount of energy is used in for pump operations, and which also, creates problem, transmitting energy to the other sectors of economy. So next slide, please. And this is one of the problem, return flow from irrigated area. We are pumping water from Amudarya, Sirdarya to higher elevation, spending a lot of energy, but due to inefficient irrigation practices, we are also returning it back, as a return flow to river system and polluting our rivers. Next slide, please. And within ongoing research projects of IWMI in Central Asia, we try to apply, water, energy, food, ecosystem nexus concept in this transboundary context in order to understand, interlinkages between these systems and what are the trade-offs, for example, exist if we withdraw more water for irrigation, there is less water available for energy. So if we withdraw water for energy, less water available, for other sectors of economy. So we also looked at, different trade-offs, and we tried to understand these trade-offs, by applying this wave nexus concept. And we also tried to understand what are the synergies exist, between these interrelated systems. And in Central Asia, water, we need water for hydropower development, as I mentioned, and we also need energy for pumping water. So, however, nexus concept is not new, but when we reviewed literature, there is less literature, less papers published in this direction, and, and also there are less quantification of nexus trade-offs and benefits at practical level, analyzed. So next slide, please. And within these ongoing projects, we tried to, in order to analyze, this wave nexus, multiple benefits in pump irrigated areas. First, we have created, geodatabase, in order to understand, geolocations of this irrigation scheme, and also, pump irrigated areas, mapping all these areas, crop cultivated areas, cropping pattern, and etc. And also documented existing practices and also best practices, which could be applied for pump irrigations in order to improve water, energy use efficiency, also reduce return flow from pump irrigated area. And we also assessed the potential impact of improvements on water energy use efficiency. And also based on our findings, we have prepared key policy recommendations for the government, in order to show multiple benefits of this wave nexus approach. Next, please. And this is a research methodology which we have used in order to analyze, water energy use efficiency in pump irrigated areas. And we have also analyzed carbon emission, carbon footprint of irrigated agriculture, because in Uzbekistan, for example, 85% of energy is generated using coal and natural gas. When we use coal and natural gas, there is associated carbon emissions, and and also it will also negatively impact to the environment. So, due to time limit, I will skip that detailed explanation of this detailed methodology, and we have created geodatabase for the region. Next slide, please. And we have also documented, best practices which is used in Uzbekistan, in Central Asia, other parts of the world, which could be applied in Central Asia context. Next slide, please. And we have developed different scenarios. For example, if we improve irrigation efficiency in pump irrigated areas, what would be implication for water saving, energy saving, and also reduction of return flow, and also reduction of carbon emission. So we also looked not only irrigation efficiency, if we, for example, modernize pumps, what would be implication? If we change cropping pattern, what would be implication? If we, for example, line canals, what would be implication? So we have developed different scenarios in order to find out optimal solution. And this is one of the example, which we have practiced, analyzed for Karshi step. For example, in the Karshi irrigation scheme, which I have demonstrated in the map, main cropping pattern is wheat and cotton, and we have collected data from government water administration, government water management organizations, and we have also collected, how much water currently they apply to this irrigation scheme for wheat and for cotton, and also we have analyzed, how much on the current status quo they are using energy in order to pump water, in order to deliver water for these crops, wheat and cotton. And we have also applied, different computer models in order to improve irrigation. If we improve irrigation efficiency, and how much water exactly should be applied, and we compared, status quo, and if we improve irrigation efficiency, and how much we gain, in terms of water use and energy use. And we have compared this, and our calculations indicated in only one scheme that, if we improve irrigation efficiency, we can reduce water consumption up to 575 million cubic meter of water, and also we can reduce energy consumption by 259 gigawatt hour, and we can also reduce carbon emissions from 413 metric tons up to 122 metric tons. So this is one of the scenario which we have developed for Karshi scheme, and but as I already mentioned, that we had about more than 10 scenarios, looking at different practices, looking at different options. Next, please. And this is also, we have practiced this exercise for Tajikistan, and our calculations indicated that if we improve irrigation efficiency, we can save up to 400,000 USD dollars under this Zafarabad irrigation scheme, which is which provides where water is pumped up to for about 30,000 hectare area. Next slide, please. And all these, project findings we have published in peer-reviewed journals. So here is, I am giving some references. Yeah, next. And we have also highlighted these project results in social media and in blog posts. Next slide, please. And also we have disseminated these project results in different policy dialogue workshops in Central Asia. Next slide, please. Yeah, next one. And in concluding remarks, I would like to mention that, our analysis indicated that, current government policy, energy subsidy in pump irrigated areas does not support water energy saving in lift irrigated areas. And if we shift some of the subsidy of the government, for example, Uzbekistan spends annually 500 million USD for only energy cost of these pumps. If we shift, for example, 30% of this amount for water saving technologies, then we can significantly improve water energy use efficiency, also minimize, return flow from pump irrigated areas, and also we can reduce carbon emissions. And in addition, we can also improve basin-wide water productivity will be improved, and also it will mitigate, competition for water and energy use in Amudarya and Sirdarya River Basin, because if we use water-saving technologies, we reduce energy consumption, water consumption, and also it will, minimize the pressure for water use in different sectors of economy, not only at national level, but also transboundary scale. And I have to mention that, Central Asia is also a data limited country. In order to make such kind of analysis, we need, we have to introduce some data platforms, and also discuss WEF Nexus issues in order to improve intersectoral cooperation. And as I already mentioned that, there is there is competition is going on between different sectors at national level, and also between countries at transboundary level. I think if we organize such kind of platform, it will give opportunity to discuss and with relevant stakeholders in order to this kind of project findings, in order to come, optimal solutions, and in order to improve existing policies and strategies in transboundary water management. Next, please. And we were also able to make a policy change at the national level. For example, in Uzbekistan, nowadays we provided all project findings to the government, and now government of Uzbekistan is introducing water saving technologies in a different level, mostly on farm level, and they are covering about 50% of this installation cost of water saving technologies. And if farmer adopts water saving technologies, they are also exempted from land tax next 5 years. And I think this kind of projects, and this kind of findings, I am sure will help to Nexus Gains project, which IWMI and with other, which IWMI, IFPRI is initiating with other CG centers in the region. And I hope, within upcoming this Nexus Gains project, we can also apply such kind of approach in order to understand, WEF Nexus multiple benefits at transboundary scale. Thank you.
Okay, yeah, thank you very much. Very comprehensive, insightful, I think, talk from a different region, but obviously there's a lot of, similarities to some extent between Central Asia and the Central Asian rivers and the Indus Basin. I think some very strong differences, some similarities. So in Central Asia, you have the subsidized energy, and obviously costing the government a lot of money, and you're pumping, you're pumping up uphill to irrigate, and then in Pakistan, the farmers themselves have to cover the pumping cost on all these private wells. So it's a very different, but also to some extent similar system. So let's see, what are there some learnings that could be applied to the Indus and the other way around. So I think that's great. Excellent. So before we talk a bit more about that, let's see if we can get our second speaker. Okay, we'll try. Yeah. Dr. Stefan Ullenbrook.
Yes,
okay.
I'm there.
Perfect.
Can I share my screen?
Yes, let's. Okay. If you could try, that would be great.
Yeah, it says I share my screen on my screen.
Okay.
Can you see it?
Show that screen? Working on. They're working on it, I think. Yes, we can see your screen. I mean, we can see the presentation, but it's not in presentation mode yet.
Now?
Perfect, yeah. Please go ahead. So our overview presentation on the Nexus and resilience.
Thank you. Thank you very much, Claudia, for the nice introduction. Yes, Stefan Ullenbrook, I'm with IWMI, and I would like to acknowledge my co-author, Claudia Ringler, the moderator of today. And we have been working a lot together over the last month on Nexus-related issues, and which I will present today. And it's about integrating water, energy, and food systems, and with the overall objective to build resilience. Just two challenges to motivate that type of research we are doing. First is food insecurity. Unfortunately, food insecurity has been increasing over the last years. This is data up to 2019. You see that particularly in Africa and in Asia, food insecurity and malnutrition has been increasing. And I think it was just to remind everybody else, all of us too, and that it's the small-scale producers mainly that produce more than half of the global food. And more than 80% of these small-scale producers actually live in water-scarce regions. So that demonstrates that water management in water-scarce regions like Pakistan is absolutely essential. A global estimate also indicates that the loss due to climate change is in the order of 10%, but I will come to that to illustrate a little bit how much more difficult that is. If you look at the more recent data, that was a publication that came out in December last year, so it's 1 year old, and there were predictions made for the COVID-19 affected hunger development, and before we were just below 700 million people hungry, and the predictions at that time were that it's between 850 to up to 900 or so million people hungry, so 200,000 more people going hungry to bed. The data that Claudia showed yesterday in her overall keynote, it was we are already at more than 900 million, if I got the numbers right. And you see how dramatic the economic and social impacts are of the COVID-19 pandemic. Overall, we have some 2 billion people that lack micronutrients, as well as 2 billion people are overweight or even obese. That's a number that is also increasing because of malnutrition in the wrong direction. The second challenge, which I would like to use today for this motivation for Nexus thinking, is climate change. Over the last 1.5 days, I think we had excellent presentations and discussions around climate change. And for one thing, the science is absolutely clear. It's about the temperature increase. This is a figure from the IPCC report that came out, I think, in August. And you see here that's the region around the Indus Basin we're looking at in the middle of the circle, roughly. This is a global map. I know it's a bit confusing with these tiles. But what we see there is that particularly hot extremes will increase. And there's also for temperature changes a very high confidence that it's actually human who caused that temperature increase. It gets a bit more complicated if you look at precipitation patterns, but we also see that overall in this region, we can expect an increase of heavy precipitation. Heavy precipitation is unfortunately not that precipitation that comes exactly when we need it during the growing period of our crops. It's heavy and often runs off directly as surface runoff, so the usability of us is often compromised. As well, it gets more complicated if we look at agricultural and ecological droughts. There is an increase expected in this region, but the significance is a bit lower, and also the amount in which this type of change is actually can be attributed to human interactions. However, it's the increase of drought and increase of heavy precipitation might be even go in line with the overall average precipitation increase, but that not necessarily makes water availability for many purposes, including agriculture, more available. On the other hand, I stressed before the temperature because I come back to that when I speak more about the Indus Basin. And therefore, I show this slide one more time. Many of you have seen that several times, but what it shows is that we have the COVID-19 pandemic, and it's the economic recession that hits society quite significantly, and there might very likely be another wave here, climate change, which has tremendous impacts for the for humans. And in no way I want to downplay anything of the COVID problems we have. Actually, I wish I would be in Pakistan at the moment. I had my travel all set up for leaving Saturday morning, but then Sunday morning, but on Saturday a family member of mine fell ill, so I'm now restricted to our house for the next couple of days. But I couldn't travel to Pakistan. So in no way I want to marginalize the tremendous impacts of the COVID and health impacts. But on the other hand, the economic and the climate change impact should not be forgotten. Water, energy, food ecosystems, we call that WEFI Nexus challenges, were worked out in a proposal that Claudia and I, with a number of other colleagues, have worked on over the last month. And on a global scale, we stress that these nexus of these systems are strongly interconnected and absolutely critical for rural livelihoods, for food and nutrition security and the economies. Yeah. Climate change is putting enormous pressure on these systems, and all of them, on the water system, on the energy system, as well as in food and ecosystems. National, regional institutions, they struggle. Often they are focusing on a single sector, and data sharing and coherent policy approaches for integrated, complicated problems is a challenge, basically in all countries we are working on, as well as for regional institutions. So even if the institutions are there, they often struggle to take that into account. Investors are uncertain. They are uncertain about where to invest best to retain forest or biodiversity, to support irrigation development in a sustainable way, or clean energy production, etc. Because it's so complex, so it's not easy said we have the 1 billion tree tsunami and then everything is solved. No, it's much more complex, and therefore they struggle, and we need a better understanding of these systems and their interdependencies. And the fifth point I want to make here on these general global challenges is that it's the women and the girls and the other vulnerable groups, elderly people, youth, handicapped people, etc., who face often the greatest consequences of not being able to manage the WEFI nexus in a sustainable way. That was a global challenge. Now a few slides on focusing into the Indus Basin particularly, and with special focus on Pakistan. And what we see is that there's a temperature increase. I think I said that clearly. And depending on which scenario you want to follow, it is always related to a decrease of the snow cover, as well as to a melt of the ice of the glacier. So it's kind of the decrease of snow cover and melt causes temporarily an increase of water. There will also be something like peak water, probably in 10 years, maybe 20 years, but then a decrease of water resources, that is at least usable water resources. And most models also predict an increase of total precipitation. Again, that's the total precipitation, but unfortunately that not falls nicely distributed to when humans want it, but often it's more heavy precipitation. Speaking again about snow and ice, it was estimated that if the current trajectory which we are on, which probably leads to a 3-degree plus temperature increase by the end of the century, about 2/3 of the ice mass will be melted. And if we have only a 1.5-degree increase, which we hope to reach, but it's very much debatable if we are not too late already for that, it still means that 1/3 of the ice masses of the Himalaya mountains will decrease. And 1/3, that's also because the temperature increase in the Himalaya is globally on average 1.5 degrees, but on continents is always higher than over the sea. And particularly in high elevation areas, it's overproportionally high, the temperature increase. And that causes this accelerated melt, which has significant impacts on many sectors. And because I'm speaking about at a water conference about the water, food, energy nexus, I particularly want to give a bit of focus on irrigation and food production in this presentation for the remaining 10 minutes or so. Here you see an overview of the main basins that drain the Himalaya mountains to the south. It's the Indus and the Ganges and the Brahmaputra. But if I may ask you to focus on the Indus system on the left-hand side, you see the darker the blue, the stronger the dependency on meltwater. So the darker the color blue, it shows that the river flow is from a larger percentage dependent on meltwater. And you see the Indus hydrograph below an average monthly regime, and you can see that during the monsoon season, even then, it is a significant part of meltwater that is actually discharging. So it's the rainfall. Well, the other further eastern basins are much less dependent on snow and ice melt, particularly ice melt. They are much more dependent on a change of the monsoon, if that comes for climate change, because it's mainly the rainfall that generates the available water resources. Therefore, also colleagues, I really like this paper, which I'm happy to share, which demonstrate the critical importance of meltwater for the Indus. And you see here the regime on a monthly basis for the different seasons, and you can see that it's the snow and ice melt that is significantly important for the total discharge, therefore also for the irrigation water. And a very high percentage, for instance, is in the pre-monsoon season, which is very critical for agricultural production. That was also mapped further in this study. Sorry for borrowing so many slides of this one paper, which I like a lot. But it just illustrates the point for the Indus very well. And what you see here for 4 main crops, sugarcane, cotton, rice, and wheat, the different dependency on that meltwater, and particularly cotton and rice, as well as sugarcane, are highly dependent. Sugarcane, of course, in the low areas, also in the delta region. And people were even mapping that and looked at how much of the yield, agricultural yield, is actually dependent on snow and ice melt. And again, when I started talking about climate change, I made the point that the science is absolutely clear. It is warm already and is increasingly getting warm. Precipitation is very difficult to predict, certainly at local scale, but about temperature increase, the science is 100% clear. Even for precipitation, it is clear, but not as clear. And you see the strong interdependency between meltwater availability as well as agricultural production, particularly in the Indus Basin, and much less on the other Himalayan catchments, which are dependent again on other patterns like the change of the monsoon. This is how the situation is today on this figure, but what we need to understand is what does it mean for which crop selection, for different types, for different irrigation technologies. As Kakramon was in the earlier talk explaining this for Central Asia, what does that mean during climate change and the change of the regime, not only in the volume, but also the shifting of the flood peaks in a temporal way? What does it mean for ecosystems, for ecosystem services and ecosystems processes, etc.? So there's many research questions that we want to study, and we want to study that in a program that we hope to start next year. It's called Nexus Gains, where we look at understanding as well as realizing benefits across water, energy, food, and ecosystems. And it's about transforming through systems thinking and strengthening this nexus thinking. So understanding and making these interdependencies explicit, and then in an integrated way manage these systems in a better way to strengthen the resilience of society. We look at many ecosystems. We give a particular emphasis on forest as well as biodiversity aspects. And therefore, I like the previous environmental flow discussion a lot, when there was a lot of discussion about the 1 billion tsunami of trees in Pakistan, which is, I understand, going to a 10 billion tree tsunami. So there's a lot of research we need to do to advise policy. We did a lot of consultations, including in Pakistan. Many of you actually participated in that. I'm happy to see some of you back. And Claudia and I recently published a so-called thought leadership article, which we are happy to share with you as well. Where do we want to work? I'm coming closely to the end of my presentation. Beside the Indus Basin, which is one of our areas where we would really like to do a lot of our activities, it's the Ganges as well as the Aral Sea, and in Africa, the Limpopo, and also in the Blue Nile system, which is between Ethiopia and Sudan. Limpopo is in Southern Africa. More basins hopefully come in if time and funding allows. Colleagues, 2 more slides. What do we want to achieve in this program in the next 3 years is around 5 so-called end of initiative outcomes. So we call that an initiative. And by end of 2024, we would like to achieve that stakeholders, and many of you are in the room or online, actually benefit and use our integrated modeling tools that we plan to develop. And they use that to assess trade-offs and synergies. That we have a better understanding of water productivity and water storage in the basin, come to that in a minute. And that we have also number 3 is that we work on scalable, gender-sensitive, clean energy business and finance models. So one of the trends that we see is coming up is the replacement of electricity and particularly diesel pumps also in Pakistan by solar irrigation systems, which is a good development, but there are some challenges related to that from environmental as well as social point of view. And we want to work with investors and policymakers to develop business models that ensure that scaling of this technology is gender sensitive and also really in a sustainable way leads to better uptake and also from a water point of view sustainably. Number 4 is we want to work on strengthening Nexus governance. And number 5 is a capacity building outcome we want to achieve. We want to train particularly female water leaders to identify Nexus approaches, to assess them and also to implement them. So often there's no lack of good ideas about the Nexus, but it lacks the leadership to actually make a difference on the ground. We want to do that, make that difference with strengthening female leadership. Last slide, Claudia, sorry, I'm a bit over time. It's just a few examples of innovations that we want to develop in the coming years. It's a decision support system for innovations to boost water productivity. That's something which would suggest to work in Pakistan, Punjab, for instance. We want to work on strategic water storage diagnostics to increase buffering of the system, to increase the resilience to climatic changes in the runoff, to increase the water use over time through green as well as gray infrastructure water storage. So before we talked a bit about wetlands and their importance in the upper parts of the basin, that's to understand that as well as gray infrastructure will help us in this way. Work on clean energy business models, as I mentioned that, a groundwater toolbox. Number 5, multi-stakeholder platforms. Biodiversity index is something we want to further develop, as well as that women leadership program. These are just a few selected innovations on which we want to work on. With this, I would like to thank you for your attention. Over. Thank you.
Okay, thank you. Yeah, great. Excellent presentation. I think also, a great reminder of the climate emergency that we are facing in Pakistan, and also in Pakistan specifically because of the glacier melt. That's a little bit more of a finality. It's a bit different from monsoon that's changing. So once the glaciers are melted, they can't come back, at least not in a bunch of lifetimes. So yeah, I think a very stark reminder of the fact that we cannot do business, the same way that we have been doing water business in the past in the Indus. So, I think in reaction to this, I think both two thought-provoking presentations, we will now hear from a series of panelists, and I'd like to call them to the stage. So we have Dr. Mohsin Hafiz from IWMI. I don't have to give any introduction. He's our one of the key organizers of this conference. So please just take a seat at the stage. And then we have Dr. Imran Saqib Khalid from WWF Pakistan. So if you could please also join us on the stage. And then Mr. Samir Ahmad Sumru from the Asian Disaster Preparedness Center. If you could please also join us on the stage. And we have an additional panelist who is online. We hope he's online. That's Dr. Babar Khan. He's with ICIMOD and probably can also give us a bit of a perspective on climate change impacts from their, from this mountainous research focused institute. But let's first start with Dr. Imran Saqib Khalid. So I think you have worked quite a bit on climate governance and climate resilience before joining WWF Pakistan. What is your reaction? To what extent can this climate emergency propel more integrated solutions across the water, energy, food and environment nexus. If you could give us your perspective, and then maybe also say a little bit of what WWF is thinking in this space. Thank you.
Yes, thank you so much for having me be a part of the conference, Dr. Mohsen. Thank you, Claudia. This is definitely a very important question in that Pakistan is beginning to come to terms with the climate crisis. We've been doing that since the floods of the 2010. We've been hearing a lot about it, but as we've moved forward since 2010, we've realized that the nexus approach is the way ahead. So it's not only the water, food, energy nexus, but we're talking about ecology here, we're talking about governance, we're talking about interprovincial coordination. So there's a nexus between all of these things. And unless and until we relate to that in a collaborative mechanisms, we won't be able to make any headway when it comes to the water crisis as it is. The earlier presentation did talk in much detail about how Pakistan is being impacted. Glacial lake outburst floods are there, glaciers. So flooding episodes, these are things that we are facing regularly. So glacial lake outburst floods in the north, then you have flooding in the plains, you have drought in places like Balochistan and Sindh, you have sea level rise, and all of these are affecting our water in various ways. So with sea level rise, it's affecting our groundwater supplies in Sindh. So that is happening. When it comes to moving forward in this regard, it's very important that our policies and plans speak to the need for a cohesive plan of action when it comes to the climate crisis. I'll give you the example of the Pakistan water policy, which calls for utilizing solar power for groundwater pumping. And that's counterproductive, primarily because of the reasons that we heard earlier, and the fact that we already have well over 1 million tube wells, and these are impacting the groundwater levels in a severe manner. So the policies and plans are not speaking to ground realities, and perhaps here the water, environment, and food nexus can really help us frame our future plan of action in a cohesive way. As to what WWF is doing, we realized a long time back that the nexus approach was the way forward. When it comes to agriculture, the use of fertilizers and pesticides are impacting the water quality. So it's resulting in better crop productivity, but our water resources are being impacted in a negative way when it comes to the quality. So we talk a lot about the quantity of water, but very little about the quality of water, right? So Pakistan's water scarcity or water stress is, we're essentially focusing on how much water is coming in. We're not talking about the amount of industrial waste that's going into our rivers and wetlands. We're not talking about the municipal waste that's virtually untreated in the country. We're not talking about the impact of poor practices, agricultural practices that result in harming of the freshwater. So in this regard, WWF embarked on something called the Better Cotton Initiative. And this was later taken up by countries such as Brazil and Malawi and a few others, whereby we focused on developing the cotton crop in a way whereby we were relying as little as possible and even eliminating the use of fertilizers and pesticides that were harmful to the environment. So this is essentially a program of action whereby we are focusing on organic cotton. So Pakistan is one of the largest producers of cotton in the world, and we think that by focusing on organic cotton, we can really move the discussion towards a more sustainable mechanism whereby not only Pakistan can benefit, but also other countries in the world. So I'll just stop here and then we can have a discussion.
Okay.
Thank you.
Yeah, very interesting. So I've heard municipal waste treatment. So I think that's clearly a nexus topic because it can pollute water and I guess indirectly also food safety, and can be very energy intensive depending on how you deal with it. So addressing water pollution, which in fact in the United States, the energy bill, municipal energy bills are to a large extent basically just used. They're so high because they have to treat so much water. The water treatment plants are very high energy consumers. So there's another linkage right there. And then you had a point on solar pumps. I'd like to take that back up because obviously groundwater, pumping is a quintessential nexus topic, and there is always this question: how do you? I mean, do you really have to pump the groundwater? In a place like the Indus Basin, it seems, especially also what we've just heard, it will be highly unavoidable to pump groundwater. But of course, you can also use it as it is already a managed aquifer recharge system. But how can you do it better? And to what extent is solar the solution, or it's not a solution? So I think we have to pick that up again. So yeah, and then organic cotton. So of course that's a interesting topic, and again there's the pollution question out there, and there's also the yield question, and there is the profitability question. So I mean, are people going to pay a lot more for organic cotton, which then might make it profitable? And that's also then, I guess, potentially of interest to Central Asia, because we have seen the graph that cotton is either the number one or number two irrigation water user there as well. So it might be good to have some transboundary exchange on that as well. But let's move over first to Mr. Samir Ahmad Somru from the Asian Disaster Preparedness Center. So yeah, I guess a similar question to you. How do you see that climate change impacts and the quest for climate resilience can strengthen water, energy, food, environment nexus initiatives in Pakistan? And maybe you have an example that you can share with us. Thank you.
Thank you very much for giving me the opportunity to share my expressions. You see, the water, energy, food nexus are linked to each other, but these are the parts of one body. If one part of body is affected, ultimately the whole body will be affected. So climate change is the factor which is affecting one or other part of the body. That means affecting the whole scenario of the nexus. So climate change is a determined fact. We are not supposed to halt the climate change. We cannot say that we are going to stop the rising the temperature and these things. And definitely the climate change impacts on mostly on water. The pattern of a precipitation has been changed. When the farmer require rainfall, there is no rainfall. When farmer don't require the rainfall, his crop is at maturity stage, there is a rainfall to damage his crop. So these are the the impacts of the climate change. On one side, groundwater is depleting, and another side, the waterlogging is happening due to floods somewhere. So in this perspective, the climate change adaptation and resilience is the important tool. We have to live in the scenario, we have to build the resilience. We have to divert our investments to the resilience. We have to build the resilient infrastructure against the climate change. We have to build the network of irrigation system which is resilient to climate change. We have to choose the cropping patterns. We have what I say, the cropping intensity, which is resilient to the climate change. And ultimately, we have to think about the crop productivity, or we can say the water use efficiency. Because water resources are not only limited, but are declining. No doubt, in Pakistan, it's a very unfortunate that Pakistan now, which is a water stress country, and it will be the first country of the South Asia which will enter as a water scarce country. So the Pakistan needs say the decisions on war on footing. So if we are determined to fulfill our food requirement, we have to increase water productivity. We have to make the vertical growth rather to horizontal growth. Definitely the climate change impacts on demand and supply. The demand of farmer is increasing. Evapotranspiration has been increased, and cropping intensity. We have the solution to increase the cropping intensity rather to increase the crop productivity. So if we are going to increase the cropping intensity, that means we need more water. So we need the sustainable access of the water, and that is possible when the prices of water are rationalized. We have the problem of water pricing, and one another thing, our NDCs submitted by the government of Pakistan mentioned that agriculture is the second most sector which is contributing towards the greenhouse gases. And unfortunately, the energy sector, they have some interventions to the NDCs. Transport, they intend some interventions to NDCs, but agriculture sector has not started yet any contribution to the NDCs. Only the wording has been given that burning of rice residue will be banned. So definitely that residue causes the smoke and contribute in that climate. But you see that impacts the farmer, that impacts the insecurity of the food. If we are making ban on rice residue, so the rice residue, its removal from the cost of the removal from the field is about equal to the half of the production of the rice. So if the farmer is compelled to remove that residue, that means he has to pay for that, and definitely that production will be affected, and what I say, this cultivation will be affected. So that need the solution. That yes. What the farmer should have the solution to do with this rice residue. either some industry may come to use that one with a good economic return, or the farmers should be given the opportunity to mulch this this as a what I say, the green manure and these things. So ultimately the recommendation is that the Pakistan government may have some such type of regulatory framework that may have a good support to the farmer, especially the small farmer. So thank you very much.
Okay, thank you. I think there could be a cost to farmers to not burn rice straw, but there's a very high human health cost to farmer families and the children in those households from air pollution. So, there's some studies on the number of hospital visits and so forth going up by children in those families. So I think from a more holistic perspective, the rice burning, the stubble really has to end. Not just from an NDC perspective. And there have to be other solutions, and there has to be help from the government to definitely stop rice burning. That's definitely, I think, a no-brainer. But it's just the fact that it hasn't stopped, tells us how challenging it is sometimes to effect this kind of change. So let's see if we can maybe get Dr. Babar Khan from ISIMOD. Is he on the? Is he online? Could we maybe get him to join us? So, Dr. Babar Khan, if you can hear us, could you just let us know what ISIMOD is doing on the water, energy, food, environment nexus, given this climate crisis and given your focus on mountainous water systems?
Thank you so much. Let me also thank IWMI Pakistan office. I hope I'm audible.
Yes.
To my colleagues there.
Yes, and you're visible too. Yeah.
Oh, thank you so much. Thank you so much for giving this opportunity to share some of my thoughts with you about the ISIMOD and also about ISIMOD's work on water management. Many of you probably have known to or are familiar with these terms and jargons that we are using, like the Nexus, the VEF Nexus, and now the more recently, the VEF Nexus. These terms have actually gained a lot of attention and traction in the global dialogue and policy recently, where these are applied to increase the knowledge of interrelatedness. Interrelatedness could be about the competitions and complementarities. In other ways, these could be like the synergies and trade-offs among various social, economic, environmental, and geographic parameters, variables, and sectors. But more importantly, to explain the cross-sector integration, inclusion, and governance coherence. ISIMOD is working in the HKH region, which is shared by eight HKH regional countries in the west, starting from Afghanistan to in the east, up to Myanmar. In between there are Pakistan, China, India, Nepal, Bhutan, and Bangladesh. Water is one of the important components. We have been working on water management using different integrated approaches. Previously on integrated water resource management, and now we are more into river basin and cryosphere management. But very recently, we have started thinking about this water, energy, food ecosystem nexus also. So today here, I would like to really touch upon what is the WEFE Nexus approach and how we are looking at from our perspective to help our partners in the region manage the transboundary river basins and river flows using this WEFE Nexus. WEFE Nexus, which is water, food, energy, and then ecosystem services, we all know substantially contributes to sustainable development goals and biodiversity, actually biodiversity targets and Paris Agreement. But unfortunately, the fate and importance of these four sectors is quite obvious, as the resources supporting these sectors like the land or soil which produce food, water, and energy are coming under unprecedented pressure and are declining quite rapidly due to growing populations, urbanization, industrialization, changing demographies, lifestyles, food habits, and climatic conditions. And the HKH region, unfortunately, more than 40% of the people are food insecure, and more than 50% of children below 5 years age are malnourished. Per capita water availability, as the speakers before me have already highlighted, is less than 1,000 cubic meters, and 70 to 80% of the households are still using plant biomass as main source of energy for domestic purposes like cooking, heating, and keeping their places warm, which means that they are more than 50% of the population in the HKH is yet to have access to clean energy. Coming to Pakistan, we all know agriculture is the second largest component of our economy. That accounts for 21% of the GDP and almost 45% of the labor force. But unfortunately, agriculture is one of the largest consumers of water also. Pakistan's agriculture is highly dependent on Indus River system, as the farmland is mainly irrigated by water from the Indus and its tributaries. And we all know Indus originates from the HKH, Hindu Kush Himalayan mountains. Hindu Kush Himalayan mountains, laden with largest reserves of ice and snow outside the polar region, they feed Asia's 10 major rivers, and Indus is one of them. Noteworthy is the climate of Hindu Kush Himalayan region has changed significantly over the past 2 decades. And it's projected to change more dramatically in the future. If the global warming is limited to 1.5 degrees centigrade by the end of this century, the Hindu Kush Himalayan region is predicted to continue to warm by about 1.8 degrees centigrade. Means that this region will be warmer than the global average. It means that since the irrigation Indus Basin is largely dependent on snow and glacier melt, and 7 out of 10 rivers in the region are transboundary in nature, the temperature and precipitation change in the high elevation and particularly in the western part of Himalayas are going to bring enormous difficulties and challenges to the people living both upstream in the mountains and hills, but at the same time for the people living in the plains and downstream, especially for the people living in riparian areas of the Indus Basin. These changes, abrupt changes, may cause huge flooding, disrupt irrigation and road infrastructure, affect energy installation, damage crops, and there could be several other forms of disasters. happening.
Yeah.
So the impact of climate change could be cross-sectoral, will not be just on the productivity of the crops, rather would be multi-dimensional. Now, water and energy have always been subsidized in Pakistan to meet the increasing demand of food for the growing population. And that has actually placed the country's land, water, and environmental resources at a greater risk of over-exploitation. Unfortunately, sectoral approaches have been generally taken to address these challenges that often overlook the close linkages between the water, energy, food, and food sectors and their resultant cross-sectoral implications. As a result, there is an uncoordinated and unsustainable use of resources, particularly these key four resources, putting water, energy, and food security at jeopardy. Our watersheds can't regulate enough water to satisfy the rising demand, and we don't have the storage capacity to hold floodwaters. Neither our ecosystems are healthy enough to control the transfer of viruses from wild to humans, means the zoonotic diseases. So we, in any case, need adaptation and mitigation approaches that are multifaceted, multidimensional, and multi-sectoral.
Okay.
We at ECMOD, from our work in the region, hope that a well-coordinated and integrated water, energy, food ecosystem nexus, which is interlinked and interdependent, can offer opportunities to build resilient socio-ecological systems, harmonize interventions and mitigate trade-offs, and hence improve sustainability. Unlike siloed developments, Wi-Fi Nexus can quickly evaluate interlinkages, synergies, and trade-offs among key sectors and actors to devise solution packages that assure enhancing water, food, energy, and ecosystem security and natural resource efficiency in the region as well as in Pakistan. Thank you. I will stop here and then I can come again if there are any questions.
No, thank you very much. I mean, it's good to know that an institute like ECMOD is taking this Nexus approach to, given the growing interrelation, across water, energy, food, and ecosystem health outcomes. So I think it's really great to know. I think what we all would like to know in the room a little bit more is what are very specific steps to address these combined challenges that are really accelerating here. So I guess I'll ask this very easy question to Dr. Mohsin Hafez. So, what's the number one Nexus solution you would propose for Pakistan? And while you think about that, I'd like Dr. Kakramon to also join us on the stage, because we'd like to open it to the audience for questions. And feel free to ask, the hardest questions you can think about, because I think they're all ready to answer them. And I think there were a lot of unanswered questions still about solar, organic cotton, governance. So there's a lot of things, anything you would like to pick up. But now that our last speaker has also joined us here, so Dr. Mohsin, what's the number one Nexus solution for the Indus? Because we have to become a little bit more concrete here. So over to you.
I think that the number one, the solution for Indus Basin is whatever we do it, because we need to make sure that we are just making not only for the research, but how the research could be translated toward the decision making. In the last 1.5 years or 2 years, since I have been interacting with a lot of policymakers and one of the fundamental questions they are asking, what exactly the water, energy, food nexus? What do you mean by that one? They consider that it's buzzword. That's the same thing for IWRM, because we need to be basically that for the solution which could be actionable, we are trying to identify the champions within the government, different ministries, and doing that sort of thing. In terms of the technical solution, I will be saying that if we cover that one, the groundwater aspect at a small area, that will be covering all the water, energy, food, nexus aspect and the ecosystem thing, because that's all integrated. Considering that the limited time, and I will be saying, Claudia will stop here, and I will be giving a time to the other, especially to audience, to ask any question. Thank you.
Okay, thank you very much. So the solution is to be more concrete and to actually, I guess, achieve some impact on the ground by implementing, let's say, a solar groundwater, recharge and pump project, or by selling solar energy in the most water-stressed areas rather than irrigating crops. I mean, those could, I guess, all be practical solutions on the ground. But yeah, over to the audience to, any questions you have to any of the speakers, and of course also to Dr. Ullenbrook, who's hopefully still online with us, and I think you might be needing this. Thank you.
You can use that one, just press the button. Thank you very much for all the panelists for your thoughts. My question is, when talking about the water, energy, food, nexus, so where does these policies of these sectors stand? Like we have water policy, climate change policy, agriculture policy, where these policies interact and how they can impact working on this nexus.
Very good, but let's catch a few more. I have seen 4 or 5 hands. So how do we achieve the integration at the national level? That is the question. Next one, yes?
Thank you very much for nice presentation. Congratulations to all the presenters. My first question to the Central Asian country, the Amu Darya Basin. So during the Russian era, it was very well managed, this basin, because they were doing this pumping irrigation in that area. So after the Russian, many people, they migrated from this area. When you move, like when you travel from this Khorok up to the Pamir, you will see a lot of these villages. They are now no more. Like the people are not living there. But again, they are now resettling the people in that area, because after 1992, many people they migrated from this area, like almost a million people from Tajikistan, they migrated to other Russian states. So my question is, any research like during this era is there? What was the impact of that less water? For example, if there were no people, they were not using the water. So what was the impact of this? One question is this from you, sir. I have another question also. So another question is from Dr. Saab, Mohsin Hafiz Saab. So in Pakistan, we have this billion tree plantation initiative. It needs, of course, water, which will further reduce the availability of water for agriculture. And then the food security will come there. So is there any study on this? How much this billion tree, the billion tree plantation initiative will use the water? Like, of course, it's starting from KP, and KP is the upstream when it's going down. So is there any study? If we don't have any study, what is your opinion on it? The general opinion, if you don't have any study. And another, can I ask another question also?
Sure.
Yeah,
all good things are 3. So, yes.
Dr. Somro, you talked about this rice burning, the rice straw burning in this Punjab and Sindh area. So ISIMOT is also working on this, because the emission, mostly the emission is coming from the brickland and this crop residue burning. So at the moment we are working on this brickland, we are converting all the brickland into the zigzag technology, and we are also working on this what they call the crop residue, this especially the rice husk, the rice this straw, which we are making pellets and biobriquette, so to reduce the emission. So the question is, anything the Sindh government is doing on this or not? they are thinking? Thank you.
Okay, so Dr. Mohsin wants to answer that. So we'll one more, and then we'll give it back to the audience. Okay, one more set of questions, please.
Now, Stefan's projections really scared me. I think we've got to believe that 1.5% or 1.5 degrees centigrade is on. Are we okay? Yeah, okay. Is not going to happen. I mean, I think it's too late in the game for that. So what we're really talking about is 2.5 to 3, maybe. Hopefully not, but maybe. If that's the case, the graphs he was showing is we may be operating with 20 to 30 to 40% less water in 2100. That's a radical change. So I would suggest that whatever, and I think the Nexus approach is actually really important in the sense of trying to optimize this kind of radical challenge that may happen, and to try to optimize across as many of these as possible. But it seems to me, okay, so what I would do is I would take rice and sugarcane right out of the mix tomorrow, and then you would solve the emissions problem as well. So take them out. Can we live with no sugarcane and no rice? And go from there, and maybe that works. So it just seems to me that one line of effort here is radical planning we need to worry about the worst cases. Hopefully they won't occur, but we need to be ready for the worst cases. And so I think that really pretty much unnerved me. So that's I don't know whether that's a question, but that's a proposal of a way forward.
Yeah, that's
maybe.
good. I was asking for serious Nexus solutions. That is one. Oh, is that a question or a comment? Huh? Okay, very last question, because we do have a final session, and people might want to take a big break before that, a small break before that.
Bismillahirrahmanirrahim. First of all, congratulations to IWMI and PCRWR organizing very wonderful and knowledgeable events, sir. And my question is one question from our friend from Central Asia. What was your project, the last or final indicator are land and water productivity? So what percentage or any figure, key performance indicator, how much there was the improvement in water productivity, and what was the improvement in the land productivity? Because this is the nutshell of any Nexus study. And my second question is to Dr. Mohsin Hafiz Saab. He is a very learned professional. Sir, our 90% water is going to agriculture sector. In Indus Basin, I am talking about Indus Basin, 1.2 million tube wells are pumping. So if we improve, it is my opinion, if we improve 5 to 10% energy efficiency in agriculture sector, and if we improve 50 to 60% efficiency in industrial or other sector, even we will get more from the agriculture sector, net benefit. So when 1.2 million tube wells are working, as per my knowledge, tube wells efficiency is very low. Energy editing in groundwater pumping is very important aspect in agriculture sector. We can save a lot. If there is any research or finding from any panelist that how much we can save from groundwater energy editing, that will be very useful for the audience. Thank you.
Okay, now over to Dr. Mohsin, who didn't use that much time before, so he gets extra time now. Please.
Thank you. Just on the first, I will start with Khadija's question about the integration of the policies. Each institute have the policies. I'm talking about the Federal Ministry of Climate Change, the energy, then the food security, and then the water. But then the problem is that those issues have been devolved to the provinces, and the provinces have their own water acts or the policies or the agriculture policies. And then the third thing is that those policies are there, but on the implementation, the ground and then the farmers or the interactor, the local government, that's where there is a mismatch of disconnection between the federal level and then the provincial level and then going to the local scale level on the ground. What we are thinking under this reaction, under how we could bring the integration without involving that all the government issues, we are trying to identify the champion. considering from each of the ministries, the people who have really outstanding, they are always pushing on that one, how these things could be integrated. So that's how we'll be bringing it on that one, and actionable ground, actionable research could be on a ground which will be impactful, and that could be helpful on doing those things there. So that's a very brief, and when we will be doing that one, we'll make sure that we make a gender balance, because when we have interacted with each of the ministry, the technical peoples are interested to do the work, but then the problem is that the policy makers are changing so quickly into the from one chair to the other chair, and that's where we need to have ownership and building the cadre of the people who will be adopting into that the water, energy, food nexus. If I put my hat for the Central Asia as a regional representative, Central Asia, when I met with the stakeholders, they are much advanced, 5 or 10 years ahead that one. They understand the water, energy, food nexus. In Pakistan context, the policy maker, they don't understand the WEF. They're saying, oh, what we are doing it and what the other ministry is doing it. So we need to make sure that we sensitize them, we basically talk about with them and what exactly that need to be done. Then linking with the Steve question, which Steve mentioned about the rice and sugar cane. Steve, I fully agree with you that this is not, I mean, this is unproductive use of water, what we are doing it. We could generate a huge potential from there, but the fundamental problem is there are no information available, and the politician sensitization to the masses there, and as well as that will need a bit more time, and there is a need of political willingness, whether someone need to take that decision. There are simple steps which we can do it. Let's forget about not the wiping out the rice or the sugar cane, but if we follow the agroecological zone and growing the crop for the area where the crop is suitable, that will at least generate 20% of the water saving without doing anything. It's the same what we are doing it in Rahim Yar Khan, which is a cotton growing area, and we are growing the sugar cane there and destroying the whole ecosystem there. That's very common in all that one, and that's where most of the politicians are involved, building the sugar mills there, and all those things are there. Coming to that, the question which Dr. Ismail asked, I think in Pakistan, it's not the issue about that one. We don't have a water. It's the mismanagement of water. We are only having the water 3 months of the period of time, and then the remaining 9 months we don't have enough water. There is less rainfall, and our dam storage is only 30 days. Typically, most of the WAPTA are, if you're thinking about water ministry, irrigation department, they are the engineers. I'm also an engineer. We always think about the infrastructure. But what we need to do it now, with the WWF is taking a lead on Recharge Pakistan, IWMI, PCRWR, other institute, we are thinking that we need to change the dynamics. We need to think about that one, the localized nature-based solution that will improve the resilience. And I think that the billion tree tsunamis, the plantation are upper part or down part, based on some of the studies which I have seen it, there are the results are there. The water scarcity is not a problem. The problem is if we harvest the locally water there, and that water will be enough to basically to improve to provide the water for that one. Even now in the previous session where I was there, the Punjab government is thinking about building the 1 canal on-farm storage at the farm level to build the resilience. And that's how we need to think about out of the box solution that will help a lot in doing all those things. Then coming to Dr. Zakir Saab, that the question which you asked, I think if based on some of the numbers which we have seen it, some of the analysis which is ongoing, the energy efficiency of the tubewell is only 40%. Why? Because we have a layman, handyman who is just there, and he will come and he will just make a decision and saying it, okay, we need a 1 horsepower, we need 1 horsepower, and the pumps are being manufactured at the local scale level. There is no standard there, nothing there. We have a meeting last week, IWMI DG, and we had a meeting with the National Energy Efficiency and Conservation Authority, and as well as with the on-farm water management. One of the critical things is which we'll be doing under the WEF project, which Stefan mentioned about that one, at least selecting the sample of the farms, the pumps, where we'll monitoring that one, how much is the energy ordered there, and what are the what are the inefficiencies there. At the moment it's around 50 to 60%. How we could save that one, not everywhere. So that's where we need to take small steps that will help us actionable ground at the pilot scale level that will be transforming to the. I will stop here.
Okay, thank you. Central Asia, I think you got a couple questions.
Thank you. Your question related to Tajikistan. Actually, I already mentioned that Tajikistan is considered one of the water tower of Central Asia, and about 50% of the water of the Aral Sea Basin formed in Tajikistan. But due to landscape, they do not have about 96% of the Tajikistan territory is a mountainous area, and they have about 4% plain area, and they have about 700,000 hectare irrigated area they used to irrigate during Soviet period. But during Soviet period, they were heavily, Tajikistan heavily subsidized by the central, from Moscow, basically. And about 60% of the population of the Tajikistan, they are very much dependent to irrigated agriculture. And agriculture is also a main job, for rural people. And after collapse of Soviet Union, all this irrigation infrastructure is, outdated. Pumps are outdated. Now they became inefficient. And in some areas, for example, due to not stable electricity supply, these pumps are not functional, and government cannot, maintain all these outdated, inefficient pumps. And in some irrigation schemes, agriculture production not become viable. For example, during Soviet period, we had big collective farms, state farms, but now land is distributed to smallholders, and if you cultivate crops in smallholder farming, it's not economically viable. And therefore, most people are immigrating to Russia from rural areas in order to earn money. And if Tajikistan's GDP capital is less than 1,000, USD, and if I'm not mistaken, about 30% of this total GDP, comes from remittances from Russia. And therefore, due to unavailability of job market in Tajikistan, most people are going to Russia to earn money, and and they are sending this remittances. Yeah. And second question related to this water and the land productivity and how much water savings, what was the impact? Yeah. Actually, as I mentioned it, we were farmers follow traditional irrigation practices, which is furrow irrigation in most irrigation schemes. And in furrow irrigation, you can hardly reach 60% irrigation efficiency on farm level. And our recommendation, we said that why don't subsidize water saving technologies like high efficient irrigation, like sprinkler irrigation, drip irrigation, and laser leveling in order to improve uniformity of irrigation on farm level. And based on our calculations and based on our observations in pump irrigated areas, within our project area, they were about 30% of energy saving, water saving, and also reduction of carbon emissions, which we have indicated in the presentation. But there are also other multiple benefits, which I already mentioned. So we also reduce return flow, water pollution to the river bodies. And except that when we use commonly furrow irrigation, due to poor performance of drainage system, most of the area subjected to soil salinity and waterlogging. And under drip irrigation, you don't need a drainage system for this irrigated area, and you can also save operation maintenance cost of this open horizontal irrigation drainage systems. So actually there are multiple benefits. Thank you.
Okay, there was
Can I respond?
and then we'll close. Oh, okay.
Thank you very much for your questions. First, I would like to compliment the answer of Dr. Mohsen Hafiz. for the question that is there a policy for WEF Nexus? So Dr. Mohsen clearly mentioned that every sector has the policy. There is a climate change policy, food security policy, all these individual policies. And no doubt there are a lot of synergies in these policies. The food security policy has a full chapter on water. Similar, the climate change policy describes the water as well. But the question is the coherence of these policies in the line of WEF Nexus. So Asian Disaster Preparedness Center is adapting one of the climate adaptation and resilience project for South Asia, and Pakistan is one of the country from that. So that purpose of this project is to enable the countries to build the resilient policies and develop these things. So recently we have one dialogue on WEF Nexus under climatic change. So we are developing, I think, a very reasonable and good policy brief, which will be helpful for the government for the implementation and adaptation. So regarding the question by this gentleman that rice residue burning in Sindh and Punjab. So this is in the both provinces there is a different scenario. The Sindh, usually the water table is high level, so they are not using the combined harvester. There is a manual harvesting of the rice crop. So ultimately they are removing that harvested material and seed and material outside the field and threshing well. And that residue is 100% used for the animal feed. That's why there is no question of rice burning in the Sindh. In Punjab, the rice harvesting is through combined harvester, and that's why the residue is left in the field. So the farmer has to decide whether to remove from that field or to burn it. So as we mentioned that some of the industries have come to use that, but that is a very, very nominal. So more than, I can say that more than 90% residue is still burned, which needs the solution. Thank you.
Yes. Okay, last intervention, and then we will close this session.
Right.
Yes, please.
Thank you. So one area that we haven't discussed, I guess we didn't have the time to do, was to explore the role of academia in all of this. And I say academia because there are researchers based in academic institutions that can help us address this issue in a coherent manner. And then they've got students who might be willing to look at the water, energy, and food nexus in a way that perhaps other practitioners might not. And there's definitely an opportunity here for Pakistani researchers to take this issue up. So when we talk about yields, productivity, we're looking at the amount of water used, but we rarely look at how much energy is used in producing a certain amount of crop, and that is an area that I would definitely like to see taken up and research highlighted. As to the question regarding governance and policies, yes, policies have by and large in this country been made in silos. We hire consultants, they come in, they develop a policy, and it might look very good and feasible, but it doesn't have any ownership. And that's because we haven't allowed the time and the processes that a policy of that nature require. You cannot make a policy in a few weeks' time or a few months' time, as has been done. It requires a collaborative approach, and you keep, it's an iterative approach, and that's what's missing. And that's why we see that there have been a number of policies, yet action on the ground is lacking. The Council of Common Interest at the federal level is an entity that whereby all the provinces are represented in it, and that allowed for the water policy to come through. So that's a good initiative, but we definitely need to keep interacting and deliberating on this policy mechanism. And finally, we were mentioning air pollution, and we were mentioning the rice stubble burning, and I just wanted to highlight that the research shows that most of the air pollution that we are seeing in Lahore and even in Islamabad is primarily due to vehicular pollution and industrial pollution. So yes, stubble burning plays a part and brick kilns play a part, but it's the vehicular pollution that's there. So gone off on a tangent, but just wanted to highlight that. Thank you.
Yeah. I mean, on the stubble burning, as I said, I haven't seen the study from Pakistan, but from India, they could show that in the districts where the burning took place, that's where the children had much higher hospital visits for respiratory disease during the stubble burning period. So yes, there's cities that are obviously affected by pollution, but the rural areas are also affected. And I think that is an entry point for behavior change, because if the families see the data that their own children are directly affected by that, maybe that's not the case in Pakistan, but I would be surprised that the same situation is not also occurring here. Okay, very last point from our colleague from Central Asia, and then we will close this session. And thanks for your really active and great participation, and also for our online presenters who were able to participate. So last point from Central Asia, please.
I think we have to also, you correctly mentioned this, we have to consider the CO2 emissions from irrigated agriculture and carbon footprint of this irrigated agriculture. And in IPCC report, it's clearly indicated that, one of the main reason of increasing temperature is due to carbon emissions. It's interlinked. If we decrease, reduce carbon emissions release, and it will also mitigate this increasing temperature in the future. Thank you.
I think on that positive note, we'll close this session. So there is so anyway, thanks for participating in the second Water, Energy, Food, Ecosystem or Environmental Health session. So I think we all have some food for thought, some ideas that we can maybe take further. We've heard students, there's a lot of research yet to be done on these topics. I think we also need a lot more exchanges across countries. We have heard some experiences from Central Asia. We heard from the rest of the ECMOD focused countries, Hindu Kush. So given the how rapid some of those changes are occurring, I think we do need more exchange. We need to come up with new ideas, try more pilots, and just also gather more experience from countries that have some similar experiences, some similar impacts. But I think it was really good to hear of the uniqueness of the glacier-related or the climate change impacts on glacier melt that is really quite unique to the Indus Basin. So that the urgency is certainly here, and so I think hopefully a lot of food for thought on how we can manage water, energy, and food systems, and also the environmental impacts much better going forward by doing things differently, doing things better. Thanks so much. And with that, we close this session. And I believe there is a closing session coming up. So maybe, Dr. Mohsen, if you want to say a word or two about that so that people know where they go for that. Yeah. And there is coffee in the back until then, but please, if you could just tell us.
Thanks, Claudia. Honorable Malik Amin Aslam Saab, Prime Minister Advisor on Climate Change. He's already here. So we will have a 10-minute break. And around 3:30, we'll be starting the closing session from here. And 3:30 here in this room. So just have a break and